Good morning. I want to thank the Open Compute Project for bringing us together today and allowing us to really continue our leadership and continue the thought leadership behind Open Compute in creating a forum for us to have an open conversation with competitors, comrades, innovators within the industry. First, we're here to discuss a couple of things. One of the most critical infrastructure challenges facing hyperscalers today is liquid cooling. And how do we do liquid cooling at scale? So we've brought together a few folks here from industry who have a lot of experience in really understanding what it is to deploy, test, validate, and create new solutions for our data centers. So I'd like to start with some of the questions before we do the introductions. So what are the things that most interest us? Shipping, wet versus dry. What are some of the rack level testing methodologies do we need to think about? And then the other is, what is the critical need for standards within the industry? So these are some of the things that we're going to explore today. So please join me in welcoming our panelists. The first, to my far right, is Finny Zhang. She's staff engineer at Google Cloud. Andy Regenball is director of infrastructure engineering systems design team at Microsoft. We have Jason Adrian, former GM of platform architecture at Microsoft, and prior to that, storage systems engineer at Facebook. Chen Chang, thermal engineer at Meta. And then Sean Sivapalan, principal engineer at NVIDIA. So we're going to start with the first question. And I'm going to address this, we're going to start with Chen.
Sure.
We recognize that yields have been challenging from manufacturing to production. What steps can we, Hive, take to ensure higher yields?
Thank you for asking. I would say this is just our recommendation and observation so far. I think throughout the journey of developing and deploying liquid cooling hardwares, we figured that the actual failure mechanism can exist in every steps, from manufacturing to testing, and even after arrival. And it's quite important to be able to forecast where those risks exist and intercept the necessary or quality check steps upfront. At the beginning, we probably will find that we might be over-investing in the resource and the steps a little bit, but as partners and ourselves get more familiar with liquid cooling hardware and develop the best know-hows, we can run those checks more efficiently. But still, my personal opinion is failure always exists, error always exists. They are inevitable at scale.
How about you, Andy?
So, wow, that's loud, sorry. So talking about this at Microsoft, we kind of looked at about 4 different areas where there's opportunities, we think. So there's capability, there's process, there's design, and there's schedule. And so just touching on a couple of those. So in the capability area, one of the biggest things I think that the ODMs need to be able to do is adapt. Things change, things happen fast, and we need to be able to root cause problems and then turn around solutions that we can implement in the build so that we correct anything that's been going wrong. And another one is testing subsystems prior to doing full assemblies. So don't wait until you have the whole thing put together to test it. Test as much as you can as you go. Those are kind of some of the key things. And then in the design area, the areas that we've been learning from is try to minimize the number of liquid joints that you have overall. Number 2, try to use joints that are reworkable. Things like tapered threads and sealants and those kind of things end up being very challenging to be able to rework. And those are a few of the key things I think that we've touched on and learned.
Thanks. How about you, Finney?
So I think it should really start from design with a robust design at the system and component level. It should also have a comprehensive validation considering the variance in operation conditions and from part to part variance.
Great. So next phase of that is, as rack scale liquid cooling moves to mass adoption, what standard testing and validation protocols do you believe are essential to ensure that we can reliably and interoperably deploy across different vendors, different geographies, and different deployment models? I'll start with you, Jason.
So as we know, liquid cooling isn't new, but what we're doing now is scaling it at really unprecedented scale and very fast. So a lot of new suppliers, a lot of new manufacturers, a lot of specifications are coming out. But if you look at components, now you have interop between many different vendors, and you may not even know who those will be. So we need to start thinking about the specs, maybe over-specifying some of the connectors and thinking about it from a system level. How do they interoperate? How do we test it? And then taking it a step further, how do we use a community like OCP to generate system-level testing, interop? You can think of this like a plug fest, like you might have for PCIe or USB, where you want to make sure that your component works with somebody else's components. Because even if each one is specified and it's compliant to a spec, what are those corner cases you might not have realized? So I think it's an amazing opportunity for the community to think that through and figure out what's next. How do we actually make sure that when you build a new system that all the pieces together are going to be leak-free? And to your point earlier, there will always be some corner cases. You want to find them in testing and validation in that interop, a lot less so in the data center.
Finney.
Yeah, sure. So I think it should also start from the design and validation. So the design itself should be designed to be interoperable from part to part, for example, the QD couplings. And for validation, it should consider the worst case scenario boundary conditions, for example, temperature, pressure, flow rate, and heat load. And that should be incorporated in the manufacturing thermal screening process for quality control. The ODM should have a consistent and repeatable process throughout all production sites and different production lines and different operators to ensure product quality, even though there's a high throughput during mass production. And there should be a good quality control from the material supply as well. And for a specific example of the thermal screening or quality control, for example, leak check. And a proper leak check should be applied throughout the process from IQC to assembly, then to OQC. Another example would be if your system or rack is shipped dry, I would recommend proper nitrogen charge, pressure, and volume before shipping.
Good. How about you, Chang?
Sure. Actually, I'm going to steal the ideas from Fanny and Jason. So from design perspective, it's really about understanding the envelope of operations, what the potential, let's say, serviceability, RMA, and interoperable scenarios. Then we define the requirements accordingly. And in operation, we should bound, excuse me. In operation, we should be able to bound the material workflow into each steps. For example, from the component suppliers to L10, L11 integrators, and then to the customer end, and define the requirements for the interface. And as Fanny pointed out, the IQC and OQC requirements should be there. And when it comes to validation, there are typical matrix we'll look at: temperature, flow rate, pressure, air leak, relative humidity, those type of things related to thermal performance, reliability, and also acceleration of certain failure mechanism to get certain, some, I would say, robust signals.
So there's been a little bit of a conversation around, especially in the manufacturing space, the preference for customers to think about whether they should be shipping wet versus dry. I'm going to start with you, Sean, on this one.
Yeah, so I think we enable both solutions. I think some of the things Fenny and Chang have mentioned on ship dry and ship wet, some considerations would be what happens with the fluid and the materials, whether it's a L10 or L11. Would there be any type of fluid degradation? Thermoxide breakdown in the glycols is one example. Would the inhibitors deplete over time? That's something that we think about. And then, I think Cheng and I have talked recently about storage of a filled rack versus a dry rack. Both are options that exist, but some of the consideration to think about with what's the temperature, what's the storage conditions, and that sort of thing. But going back to shipping itself, I think with it being filled, would you use a temperature-controlled truck or not? What happens during air shipping? Will the fluid be exposed to certain temperatures and that sort of stuff? So I think they're all important considerations that an ops team or a deployment team have to think about in the long term.
Andy, I'm going to come over to you.
Okay. Yeah, so Sean articulated quite a few of the things that, are pretty common. One of the other things, though, I think that we need to take a look at is which components are we actually talking about? Are we talking about FRUs? Are we talking about node level? Are we talking about rack level? Or even things like, HXUs where there's a very large quantity of the fluid? And I think we might find out that the answer may be different depending on what level of component we're talking about. If it's just a cold plate, you may want to consider shipping that, wet, so that you don't have to do the continual, fill, drain, flush, nitrogen, So if you look at the process, some of those things could end up having to happen multiple times, and it's kind of a waste of time, effort, and causing potential problems with the part. So I think considering what level of device you're talking about, the answer may be different.
Chang?
Actually, Andy just said what I wanted to say.
Sorry.
Yeah, no worries. Thank you, actually. So shipping wet or dry, to us, is not a binary decision. It's really a comprehensive logistic, I'll say, protocol. So depending on the technical risk, logistical resource, and also operational capacity, we may be able to make an optimal decision whether ship wet or dry, depending on what stage of manufacturing, what platform it is, and also what is the transportation route from factory to data center. Sometimes people were treated as a very binary, strong topic with strong opinions, but it actually doesn't have to be like that. And we have seen across a lot of examples where we can actually ship either wet or dry. And as a user, we want every product to be able to support shipping wet or shipping dry.
Sure. Finny?
Thank you. So as of today, it is still practical for us to drain and purge dry a L11 rack level cooling loop. So therefore, our preference is still shipping dry, considering some of the challenges during transportation and storage. However, it's being studied to ship wet and filled as an option for the future. So currently, we're still looking for improvements of the purge and drying process, and we're looking for better equipment. So if your company has the solution, please reach out to us.
Thanks. So another conversation as we start to progress with the different technologies that we're leveraging today, which is direct liquid cooled, is one of the technologies that we're doing today to address some of these thermal challenges. What do you see in the future as some of these next generation technologies, say immersion cooling, that we might be able to leverage in future data center builds? And I'll start with Jason on this one.
Right, I would separate it in maybe two categories. One is, what are we going to do at the component level, and what are we going to do at the system level? So let's start at the component level. We're already at a kilowatt plus on an ASIC. That's going to continue to grow to multiple kilowatts. We have HBM technologies. We have to figure out how do we keep this cool. So I think the next few years, we're going to see new and novel cold plate technologies and designs that are going to enable us to get that heat away, because you have the die, you have the HBM. You may see two-phase direct-to-chip. Things like microfluidics are interesting as well. You're going to see all of these incubating. Some will make it to production. Some may actually get delayed for a few generations until they're needed when the trade-offs are forcing a different type of technology. And then if you think about that from the system level as well, what are we actually going to do at a system level? You see that speeds and feeds are going very fast. More GPUs, more accelerators are being put into a rack. That's having density challenges right now. If you want to continue with copper, you're trying to force everything together. You're going to see more of the system becoming liquid cooled of some sort. Maybe less so on immersion cooling directly, like immersing the entire blade. It's very challenging. But I think the big wild card here over the next few years is, what do we do with optics? Because that density challenge today is really driven by staying on copper. When we get CPO, LPO, micro LED, things that allow you to scale optics in an efficient, power-efficient, cost-efficient method, then your density is not trying to get shoved into one rack. Now you can start moving it across multiple racks or a row. That's going to free up a little bit of the space. But it may also cause new challenges of, how do you cool the optics? What does that look like from serviceability? So you're going to see this dynamic of copper and optical. What trade-offs are they driving in a system level? That drives the cooling challenges. And we'll see new technologies emerge that will hopefully solve all those challenges.
Finny?
Thank you. So we are evaluating different cooling technologies. To give it a specific example, for example, immersion cooling. And the technology is interesting, but we anticipate more work in this area needs to be done to outperform the current liquid cooling roadmap we have. We'll continue to monitor what the industry have in this development.
How about you, Chen?
It's an interesting topic, I would say. To us, DLC, a single-phase DLC based on PG25 is the first technology we use to develop, to deploy those high-power racks at scale. We still think there are still a lot of potentials to be evaluated from in this space. Like Jason called out, improvements in the packaging level, and also between the cold plate solution and the package. Beyond that, I think there are many technologies out there. Two-phase DLC, immersion cooling, for example, they have demonstrated very good potentials in the past. But when it comes to mass production, when it comes to really claiming those improvements and getting the key values on the products, it takes time to develop. And it will be exciting to see further progress in those space, and it's great to see that actually the community already have some work stream on them.
Yeah, thanks. Andy, get your perspective.
All right, being the last guy to go. So, like everybody on the stage, we're all kind of looking at advanced technologies and different things, and probably all looking at mostly the same things. But we kind of see that direct-to-chip single-phase cooling is going to be the dominant technology for a few years to come. Two-phase direct-to-chip has some interesting opportunities. There may be some different ways to look at how you convert the vapor back into a liquid that could be advantageous or disadvantageous, depending on how you look at it. Microsoft did a lot of work in immersion. I think it was made public a little while ago, and we're currently kind of on hold on that technology, although we are continuing to evaluate and do research into it and looking to see if there are opportunities going forward. And the being able to do the cooling within the chip, which is going to the kind of cool technologies now. You can actually go and see a demonstration of that over at the Microsoft booth. That's a potential game changer going forward, but there's a lot of work to do there to make sure that it's a viable technology. So that's kind of some of the things that we're looking at.
Great. that kind of sums, the questions that I had, but I would like to give, you guys just an opportunity. I'll start with Sean. Any additional comments or anything around this particular topic?
Yeah, I think everyone hit on the key points. I'm just glad to hear everyone's insights on what we think is coming. I think it's an exciting time, particularly for OCP. I'm on the cooling environment side, but I think it spans multiple projects, data center facilities, sustainability, server hardware, all above. So I think this is maybe a message to everyone here to join in where you can. We'd love to hear your thoughts, and looking forward to hearing some questions.
Great. Cheng, any closing remarks?
Yeah, I would say in the OCP you have very successful work streams and release of specs, guidance documents about liquid cooling design and what about alternative technologies in the past. I think in terms of the actual production, deployment, processing, those type of things, really a lot of things to be further improved and hoping be able to learn from the community into this domain further and helping the scaling become more easier.
Yep. Jason?
So I think you can see we have a lot of the same challenges. We have a lot of the same speculative investments on what's going to work, how do we solve it. I mean, this is what OCP is all about, right? It's coming together, figure out how do you drive standardization, how do you actually have the debate, because maybe it's not 100% overlap, but we're close enough, have the debate, have the dialogue, and find a way to standardize. I mean, that helps all of us here figure out what to do next and how to be successful. It's from the CSPs to the component providers, the integrators. It helps everybody along the way. So join us.
Thanks. Andy?
Yeah, and I think one of the key things that's been mentioned is, the being able to design around common components, interoperability, creating standards around things that make the things that aren't really a differentiator be common and usable and interoperable, so that there's a large supply chain and it's very straightforward to build your designs around high functioning interoperable components. I think that's one of the key things going forward.
Yeah, thanks. So I think it's really the whole industry needs to collaborate in this area to enable interoperability and a better product for the liquid-cooled IT system. Meanwhile, I want to say that Google has an open CDU in the expo hall that we collaborate with many different partners in the industry. So you're welcome to stop by and take a look.
And actually, you bring up a really good point there, is each of these panelists here represent different companies, different approaches, yet they have one theme in common: standardization. I think each and every one of us heard that same. Jason has said it at least a dozen times, I think. But no, it is true, is really starting with standards. And OCP, we want to thank OCP once again for creating this forum where we have, in some cases, competitors, but certainly comrades, all together on the same stage to talk about something that's really, really important for us as we move forward. Some of the challenges that we have here include not just wet versus dry, or how do we manage the supply chain upstream, but also how do we manufacture and how do we test and validate before it even gets to the data center. So it does help us at Hive in that dialogue, in that change, in how we can better our environment, as with other ODMs, to really ensure that we can land racks efficiently, effectively for our customers. I also want to thank OCP once again for hosting this and creating this forum, as I said, but also creating the dialogue around liquid cooling. It's been one of those new tracks that has been introduced here at OCP only in the last about 4 years. And you can see the amount of conversation going on here. Just assume that just continues, in every single hyperscaler, and how we deliver racks at hyperscale, right? So I'd like to ask for a round of applause here. because these have been great panelists for us. And I don't think we really have any time for questions, but I will say this. These individuals will be probably in the back of the room to answer any questions that you might have, but I also encourage you to go to their respective booths. Please join the Hive booth as well to discuss a little bit more about what the standards are, what ways we can actually collaborate in this particular forum. So thank you very much. Thanks all.
Actually, we are ahead of the schedule. So would you guys mind taking a few questions?
Maybe, yeah.
Is that okay?
If
Just want to make
individuals-
sure it's okay.
Oh, absolutely.
So if you do have a question, there are 2 microphones in the middle here. Please make sure to bring up to the microphone your question, just because these sessions are recorded, okay?
Hello, Jim Winan. Question perhaps more for Sean. So your counterparts in China, the hyperscalers, are notably moving into single-phase immersion at scale much more rapidly, with companies like ByteDance with hundreds of thousands of servers currently running that. I'm curious, Sean, how do you handle those as their ODMs are developing these systems, the warranty and testing to ensure that they're covered in that environment?
So unfortunately, I'm actually not going to comment on immersion cooling. I've got to leave that to my counterparts on the product side. I can point you to them afterwards, but yeah, thanks.
Thanks. We have a question over here on the right.
Yeah.
My right.
So I think you talked about immersion cooling challenges. If you can throw some light on the challenge that you face in real time, that'd be really helpful for us to understand. So what challenge do you face, and why it's
For immersion cooling.
yes, immersion cooling.
I think really the only panelist that really has been, looking at immersion cooling and really talked about it was Finney. I don't know if Finney, if you're able to comment on that.
There are multiple challenges we've seen in this area. Currently we evaluate it, but its performance isn't outperforming what we have on single-phase liquid cooling cold plates, and so we're continuing monitoring, but we don't have plans to apply this technology currently. Yes.
Thank you.
Yep.
Another question here?
Yes, Sam Nag from Machinimo Controls. Obviously, industry is very fragmented right now with a bunch of different solutions with ALC and DLC, one phase, two phase. So my question really is that what's the future look like in terms of data centers? We saw a talk somewhere, I think this morning, that said 60% of the data centers today are still legacy data centers, right? So how do you see ALC and DLC coexisting? And immersion's got some challenges, like you said. But I'd like some comments on that in terms of where the industry is going with ALC, air-assisted liquid cooling versus direct liquid cooling. Yeah. Andy?
I might, Jason, you want to?
Sure. So you're right. There are a lot of legacy data centers that are air-cooled. That's why you see a lot of these heat exchangers out on the show floor. That's kind of the keep you going without redoing an entire data center. But all new data centers are going to be designed for liquid cooling. Maybe it's 100%, maybe it's not, because you're going to have an intermix of AI systems that benefit from liquid cooling, whereas compute or storage may not. So you're going to see new investments enabling that, but you always have all of the land and all of the other data centers that you want to keep operational. So that's why you're going to see more of the air-assisted liquid cooling systems. I don't see that going away for quite a while.
I have, I think, time for one more question over here.
Okay, thank you. So we didn't plan for the question to be similar, but really it's about, so hyperscalers are leading the charge towards implementing liquid cooling at scale. Liquid cooling is not new, as Jason pointed out. It has been in the industry for a long time, but it's a scale that is unprecedented. And since hyperscalers are leading the charge, I wonder, in the spirit of Open Compute project, how are you as hyperscalers supporting the data centers or the enterprise cloud providers to also catch up with this technology, just because it's not a resource that everyone can implement, and it's not as mature. There are some regions of the industry that may have some concerns about it. So how can you continue to leverage this knowledge and transfer this knowledge in order to make it mainstream, really, not only for the big 5 hyperscalers?
Andy, would
I
you be
didn't,
able
the
to?
question wasn't clear. Can you maybe make it concise, more concise for me?
Yeah, basically, how are you transferring your knowledge in terms of implementing
okay.
liquid cooling
Yeah.
to help the smaller players?
Yep.
Okay, so I think being here, right, being at OCP, contributing things that we're doing to OCP, that's the main way that we're trying to enable everyone in the liquid cooling environment. That's the main opportunity that we have, I think, and we will continue to do that. I think most of us are doing that at different levels.
Yep.
Actually, I'll add, I'm going to put Cheng on the spot. So some things have been contributed to OCP, like
Yeah,
the paper was in
thanks.
2023.
Yep.
I was
yeah.
one of the co-authors, so maybe you want to elaborate on that one?
Well, thank you. Actually, from Meta side particularly, we really like sharing, and especially myself, my colleagues, we're willing to learn from each other in the industry and also to share our knowledge with the industry. And actually, I bother everyone on this panel here almost every quarter. Well, most likely sharing through the OCP forums in the shape of presentations, white papers, guidelines. And also, we have a lot of collaboration with the system integrators and also cooling solution providers to develop know-how together. I think every year or every quarter, as you talk with your partners in the ecosystem, you'll probably get some learnings and hopefully being helpful that were shared by hyperscalers. And of course, we don't think we are the only smart people, only talented people in the room. Everyone has a point, and we really want to see everyone start sharing.
So with that, we are going to close the session, but I see a couple more questions. Feel free to grab them at the end. And I want to thank, again, OCP for this opportunity. I want to thank you for attending. Very well attended, thank you. And again, finally, our panelists. So thank you very much.